VR sculpting is awesome. Currently, creatives can create highly complex 3D forms while experiencing benefits of real space sculpting like proprioception and spatial awareness. But while the softwares themselves have ported nicely from the 2D screen to the AR space, the interaction paradigm supporting them may not. Stamping, scroll wheels, hand-bevel menus, where in real life all we have to do is to change the angle of holding our brush. Suspecting that these could be more intuitive, I rendered interviews using ShapeLabs, one of the foremost products for VR modeling on the market, or specialists familiar with different sculpting processes, digital or virtual. When challenged to create a simple, smooth surface, they often had to switch between 5 different brushes and intensities to achieve what in real life could be done in a flick. This thesis began inspired by the archetype of a hammer and a chisel. If a controller could receive directional kinetic input, could that result in a more intuitive, enjoyable, and sensitive digital sculpting experience for users new to VR? In VR research, a haptic proxy is a physical object used to simulate the sensation of touching a virtual object by aligning virtual interactions with tactile feedback. I worked with a classical sculptor and contacts who are either familiar with or professional 3D modelers, producing experienced prototypes that first established 3 different relationships between tool and proxy. For example, was the receiver anchored on a pivot or freehand? Should its topology try to represent the virtual surface or find a generic one like a sphere? In these different frames, I asked them how they envisioned removing or adding or changing the virtual surface with their physical actions. This led to 12 interactions like slapping a wad of material with a ladle, hammer and chiseling a sharp angle, or pulling material with hands. I tested different types of tool tracking and built several basic mesh deformation engines in Unity. Users performed tasks while thinking aloud, like adding ears onto a dog, filtering a nose, or carving a smile. There was a rapid rush of prototypes to find an omniform that could represent any surface, but then one set of tests with clay sculpting students changed this. In the industry, making VR tactile has always been about these complicated contraptions to align physical surfaces to virtual ones. But sculptors have always done the opposite, taking unideal plastic surfaces and then enforcing their reality onto it. What about a new system? The system tracks the position and topology of a basic known object, like our hands, and projects these surfaces into VR, thus introducing more dimensions of intuitive control, like pressure and tool angle, while creating hyper-accurate, smooth surfaces at a fraction of traditional compute costs. This project is a vision of spatial computing that brings digital craft right back into the realm of craftsmen, restoring sensuality and intuitive handmaking and improvisation, while making hyper-accurate, high-resolution sculpting real-time and accessible for potato computers everywhere. In a future where the digital escapes the 2D screen back into the 3D spaces around us, I hope this new paradigm of spatial interactions can demonstrate that with a little innovation, we really don't have to reinvent the wheel of interaction.